Now question number 9 will be the one question which I will not solve and leave it up to you to solve. Question number 9 is very similar to question number 8. So in question number 8 we had 2 OH groups and very patiently we did dehydration on both the OH groups. Now on question number 9 we have 3 OH groups, and with a little more patience, if you do dehydration on all the 3 OH groups one by one, you will get to a final product as we got in case of 8. So I'm telling you that the product of question number 9 will also be benzene. Now this you have to convince yourself for once and for all time by using paper and pen, not by just looking at the question and analytically thinking. If you don't solve it, you're deceiving the purpose of learning. Do it. Solve question number 9. Do the entire mechanism. That will practice. That will the process you will have practice, and also you will develop confidence in writing the mechanism. So I'm giving you the answer. Answer would be benzene, but you have to get to benzene, convincing yourself at every step with conviction. So that's question number 9. Now we'll solve the last question for dehydration, and then we'll move on to reactions of alkene. Question number 10. Suppose this is a question and you have to carry out dehydration for this. Substrate. Fine. So first try out getting your answer and then peep in for seeing the answer. First step, protonation. So let's do protonation. Now these are 3-member rings, right? So first step is protonation. Done. Second step, removal of water molecule. Let's remove water molecule. Done. Now before going for the third step is the acid-base reaction, and now here you can see there is no scope of acid-base reaction because this carbon is having 4 valency with other 4 carbons, so there is no hydrogen on this carbon. There is no hydrogen on this carbon either. So even if you try, you cannot do dehydration. Suppose if I take a methyl group here, then this methyl will be here as well. So now you can actually do dehydration because this carbon is having hydrogen. Fine. So you can go for now you can go for acid-base reaction if you wish. But before going for acid-base reaction, as I have told you, migration is a very fast step. So migration would already occur before a base would come and participate for acid-base reaction. So you have to check whether this carbocation can be further stabilized, whether there can be a migration before acid-base reaction can occur. So now this 3-member ring, as I have told you before, 3-member rings, 4-member ring, 5-member ring are strain ring, and they always are keenly looking for opportunity to expand and to ease up their strain. Now this 3-member ring, right outside the 3-member ring we have a plus charge. So the 3-member ring has an opportunity to expand and ease up its strain. Now this 3-member ring is not going to lose that opportunity. We may lose the opportunity to solve correctly and get the major product, but this 3-member ring will never lose the opportunity to expand and convert into 4-member or subsequently 5-member if possible. Here if we expand, if we migrate this bond from this carbon to this carbon, as we have been doing, so I'll do it straight away. So this 3-member ring now becomes 4-member ring and the plus charge appears here. Now this 3-member ring gets an opportunity. So if we migrate this bond from this carbon to this carbon, if we do it from this carbon to this carbon, so the plus charge from here will shift to this carbon. Now to write it properly, since you have 2 carbon here and 2 carbon here, let me write it properly and present it like a 4-member ring. So now this 3-member ring has converted itself to a 4-member ring, and the plus charge appeared here. Similarly, that ripple effect will go on, and this 3-member ring will again convert into a 4-member ring by ring expansion, and the plus charge will come here and this bond will go there. Now this 3-member ring has opportunity, so this 3-member ring will also be converted to a 4-member ring, and similarly this 3-member ring will also be converted to a 4-member ring, and finally the plus charge will come at this position. Right, now since all the strings has been removed, and now you can go for a dehydration reaction. So actually let me remove this methyl, because there will be a problem because there is no hydrogen on this carbon, so there cannot be a acid-base reaction. So just remove that methyl group, and now we can have a dehydration reaction. Because this carbon is making 3 bonds, it has 1 hydrogen as the 4th valency. So now the base can come in and remove this hydrogen, and we get alkene as the final product. Right, so this will be the final product of this particular substrate. Fine. So we have reached the echelon for this topic. This is the maximum tough problem that can be asked to you in any of the competitive examination. So we have completed dehydration full sum. We have studied all the methods, relevant methods of preparation of alkene. There are other methods of preparation, but actually those would be the reactions of some other functional group, and those we will study at proper place there and then. But for time being, these are the important method of preparations of alkene, and now we move on to reactions of alkene.